Hello, this is Mrs. Williams from Tyler Legacy High, and we're going to continue our studies with the segment addition postulate. Here's an example. We're at number 5. It says, write an expression that shows the length of Km, then simplify your answer. I know it's kind of fuzzy, but if you will get your copy and just follow along. Well, the segment addition postulate says that if you have 3 collinear points that are on the same line, one of those points is between the other two, and the two segments that are formed are together. The sum of those two segments is going to equal the whole of the segment. So in other words, KL plus LM, this part plus this part, is going to be equal to the whole. Part plus part equals total. So I'm going to sub in. For KL, I have x plus 10. For LM, I have x minus 6. And I'm combining those. Well, you don't have any subtraction. This is just addition. And remember that it's understood. That's an understood 1. If I multiply 1 times x, I get x. 1 times 10, I get 10. 1 times 1x, I get x. 1 times negative 6, I get negative 6. In other words, the parentheses are not needed in this problem. So I have x plus 10 plus x minus 6. I put my like terms together and I get 2x plus 4. 1x plus 1x is 2x. Positive 10 and negative 6. The signs are different. Subtract. Take the sign of the larger. So Km is equal to 2x plus 4. Okay, let's do another one. Here's an example. I want to have plenty of examples. Okay, this is JAC. This is line, 3 collinear points, J, A, and C. Okay, JA has a length of 2x plus 11. AC has a length of x minus 5. I want to find the length, the total length of JC. Now, this is not going to be a numerical value. I don't know the value of x, but I do know that x stands for a number. So, the segment addition postulate says that JA plus AC is equal to JC. So, I'm going to substitute in. JA is 2x plus 11. I'm going to put in parentheses. That added to x minus 5. And that should give me my total length. Okay, there's an understood 1 here. 1 is our identity, multiplicative identity. So if I multiply by 1, I'm simply going to get 2x plus 11. X minus 5, I'm just going to get x minus 5. It's not necessary to have the parentheses there. Now hold that thought, because we're going to do some problems where it will be necessary to have that parentheses. I put my like terms together, I get 3x plus 6. The signs are different, subtract, take the sign of the larger. Okay, let's go to, so the length here is 3x plus 6. That's the most that we can do because we don't know the value of x. Okay, let's go to example 6. On example 6, it says write an expression that shows the length of KL. Well, KL is this missing part right here. That's a part. So remember, the segment addition postulate says that if you have 3 collinear points, one is between the other, and the 2 part segments will be equal in length to the one whole. So with that in mind, we know that KL plus LM is going to be equal to KM. Now, we know the total already, and we're looking for a part. So that means what we need to do is we need to take the total, which is Km, and we need to subtract the part that we know, which is Lm. And that should give us the KL. Now don't get bogged down into what the letters say or what they mean. You're going to take this total, or this whole, which is 2x plus 20, and you're going to subtract the part, which is x minus 3. Okay? Now, we know that there's an understood 1 here. So, 1 times 2x is 2x. 1 times 20 is 20. But here, there's an understood 1, but look at what we're doing. We're distributing a negative 1. So, parentheses are important here. Otherwise, you would be subtracting the x and subtracting a 3. But that's not what we want to do. Negative 1 times x is negative 1x. Negative 1 times negative 3, our negative times a negative is a positive. So we want to make sure that we get this kind correct. 2x minus 1x is 1x. 20 plus 3 is 23. That's the expression that represents that missing link. Let's get another one going. Another example we would be ABC. This is going to be A. This is going to be B. And this is going to be C. Now, BC is going to be 3x plus 2. And the total here, the whole, is going to be 5x plus 9. Okay, let me move that up. Make sure that you can see that. Okay, when you have 3 collinear points, one of those points is between the other two. So we know that the two parts are going to be equal in length to the whole part. Okay, so in other words, AB, the length of segment AB, plus the length of segment BC is going to be equal to the segment length of AC. But now when I know the total, what I want to do is I want to take the total length, the whole, and I want to subtract the known part, which is BC. I'm going to make that a minus, and that should give me AB. So let's substitute in. AC we know to be 5x plus 9. Okay. And we want to subtract BC, which is 3x plus 2. Okay, we know that there is an understood 1 here. 1 times 5x is 5x. 1 times 9 is 9. Now, there's an understood 1 here, but look, we're distributing a negative 1. So in other words, each one of these terms in here, you're just going to change the sign. So that would be minus 3x and minus 2. The signs just change. Okay, we'll simplify. 5x minus 3x is 2x. 9 minus 2 is 7. Okay, and that is the expression that represents that missing length. So now what I want you to do is we are going to stop, and I want you to complete numbers 9 through 18 on the guided practice review. When you're finished, I want you to proceed to the next lesson. Thanks.